This first bit just carries on from yesterday, actually. It's another trig substitution with using t result. If t equals tan x on 2, then obviously we know our t results. Sin x is 2t on 1 plus t squared. Cos x is 1 minus t squared on 1 plus t squared. Now, if I'm going to use it as a substitution, I need to work out what the t is. Well, the t dx would be a half sec squared x on 2. And sec squared is 1 plus tan squared. But we said t was tan. So we get a half of 1 plus t squared. So dx to t is 2 on 1 plus t squared. So dx is 2 to t on 1 plus t squared. No, you don't have to derive that each time. It's just another t result. So if you're using t results, then just like you can say sin x is 2t on 1 plus t squared, you can say, well, dx is 2 to t on 1 plus t squared. That is, of course, if it's tan x on 2. It's good for questions like this. So you've got dx over 7 plus 6 cos x. You can't create the derivative there. And you can't really do it by parts either, I don't think. It'll get a bit messy if you tried, I think. So if you just simply do, I'm going to do the substitution. T equals tan x on 2, which means dx is 2 to t on 1 plus t squared, and just sub straight in. Of course, the beauty of the t results, we mainly use it for just sine and cos, because then the denominator is the same, 1 plus t squareds and everything. So you can multiply by the 1 plus t squared, and we just end up with a polynomial, some rational function that we have to integrate. In this one, inverse tan. Inverse tan. So we've got 2 on root 13, inverse tan t on root 13. The main thing, I guess, is don't forget to substitute back in for t. So t is tan x on 2. So 2 on root 13, inverse tan x on 2 over root 13, plus, of course, a constant. That doesn't stop you using t results for other things. I mean, if you want to make t equal tan x, that's fine. But the t dx ends up being, eventually we get there, the t on 1 plus t squared. So in general, if you're going to make t equal tan x on a, okay, go through it, dx ends up being a to t on 1 plus t squared. So we're usually doing x on 2, so we end up with 2 to t on 1 plus t squared. But if you're using t to represent tan something else, that's fine, you can do that. But your derivative will end up being something different. So it's a to t on 1 plus t squared.